Hello and welcome to a Minitab lesson on how to do confidence intervals for proportions. So over here I have my Word document open on the confidence interval for proportions, and I have my advertising data open in Minitab, and we're going to start off by reading the question completely because that's what you should always do, you know? In a sample of Reese's Pieces, it is found that 109 of the 200 candies were orange. Calculate a 95% confidence interval for the proportion of all Reese's Pieces candies which are orange. Does orange represent 50% of candies in Reese's Pieces? So the first thing I'm going to do is I'm going to go over to Minitab to calculate this confidence interval. So dink. And to do a confidence interval in Minitab, we go up to Stat, Basic Statistics, and down to a 1 proportion. Now the first option it's going to give us is I have one or more samples in each column, but I don't have this isn't candy. This is for the second question. This is, the age advertising data. So I actually have summarized information here. I have counts of data. So when that happens, I want to switch this first drop-down menu to being summarized data. And then it's going to ask me for the number of events. Remember, events for us are successes. That's my 109 orange candies. My number of trials is the 200 times the 200 candies that are in the bag. And then I'm going to go ahead and hit the options key. When I'm doing any type of testing in Minitab, I always look at what my options are to make sure I have my set up correct in order to have appropriate answers here. So I'm going to go ahead and hit the options button. I notice that this is set to be 95% for my confidence level. That's correct because I want to do a 95%er. The next thing I want is the alternative hypothesis is set to be not equal to. That's something that we always want when we're doing a confidence interval, because if you change this to anything else, it's either going to produce the upper or lower half of the interval, but not both pieces. So I want both pieces, so I'm going to go ahead and leave that as is. And then I'm going to go down and go ahead and select normal approximation mode, because that's the actual mode we use to calculate our confidence intervals using z-scores. After you have this set up correct, we're going to go ahead and hit OK. And then hit OK again. Oh, one last thing. I forgot to say this. If you're ever in Minitab and not sure where you got this menu from or what menu you might need to do something, notice that it always tries to describe for you where you're at. I'm in a one sample proportion and I'm in the options button. Whatever one you opened last is what appears last on Minitab's list of things here. So it's kind of trying to help you. I'm going to go ahead and hit OK and then hit OK again, and then it's going to produce this output for me. This output has several parts. It has your number of successes, which represents X, your sample size, which is N, and then it gives you the sample P, the sample proportion, or your P hat, and then it gives you your confidence interval. This is the part I'm actually interested in. So I'm going to go ahead and copy this over to my output, which it always wants to enumerate and drives me mildly crazy for that reason. I'm going to tab this over and make it a little bit bigger. All right, so there's my confidence interval. Good times. That's about all I wanted to do. So if you wanted to know some other things about your confidence interval, like say maybe you wanted to describe it, we would say something like we are, well, not something like this is exactly what you say. We're 95% confident that the proportion of orange candies in all Reese's Pieces. So remember, this is a bit of inference, which means that I'm always talking about the population using sample information. That's what a confidence interval does for you, is between, scroll back over please so I can read this, 47 point, I'll round up, 60% and 61.40%. I'm including the zeros there because it's making the individuals aware of the fact that I rounded all the way to the second decimal place. There's a difference between 0.614 and 0.610 precision. Anyway, this is how all of your interpretations of confidence intervals should look. It talks about the confidence level, what the actual proportion was. It should be specific to the object that you're looking at. In our case, it was orange candies and Reese's Pieces. And actually report the confidence interval, so my between 47 and 61. You could also do this without using the percentages. You could just use the proportions themselves, like the 0.4760 or however well you want to round. Okay, what's something else you might want to be able to gather from your confidence interval? Well, let's suppose you actually wanted to know the margin of error. Again, these weren't in the question. I'm just adding them for fun and things. So this is a very typical question that you're going to get asked, especially in your homework. I'm hoping you noticed that Minitab didn't output the margin of error. It gave you the confidence interval and it gave you the sample p, but there is enough there for you to be able to find the margin of error. So I'm hoping that you remember how we find a confidence interval is we take the sample proportion and we add and subtract the margin of error. So we add the margin of error to get the upper part and we subtract the margin of error to get the lower part. So remember, the very center of your interval will be the sample p, which means sample p is always in your confidence interval. One of the common mistakes I see students make is they'll look at this and they'll observe, oh my gosh, well, the sample p is in there. Well, yeah, it's always in there. It's how we calculate this. It's not useful. Stuff like part B will be more useful. Anyway, so the idea is my sample P is directly in the middle. I added the margin of error to get to the upper part. So sample P plus something makes this guy, which means I can just subtract sample P to get margin of error. So what's my margin of error? Well, it's 0.61414 minus what my sample P was, 0.545. I don't know what that number is. So you might be tempted to be like, oh, frick, what am I going to do? I'll go up to calc and then calculator because that'll help. Wrong. The Minitab calculator does some very weird things, and it likes to add and subtract and multiply and move things around with variables, not single values. Since I'm just interested in doing a simple subtraction, I actually don't want to use this menu. What I'm going to use instead is I'm going to go up to Tools and open myself up a Microsoft calculator because it's a nice and simple way to do this. So this is the standard calculator in Windows 10. And I'm just going to type away in this bad boy and get my answer. So 0.614014 minus me reading numbers, super not interesting, and that gives me my margin of error. Now, clearly you could type your margin of error by hand by doing like finding your z-score according to your confidence level, finding your standard error and multiplying, which isn't too bad. But you know, if you're going to use Minitab, you might as well use it to your full advantage. So there you go. There's the quick way to get margin of error off of Minitab. All right, so let's go to a question. Hey, does orange represent 50% of the candies in Reese's Pieces? And here's where we need to be careful, because that's in there, which means it is a possibility that that is the proportion of all orange candies in Reese's Pieces. It doesn't tell you if it is or if it isn't. It just tells you that it's possible that that would be the actual value. So it's possible. In fact, you're 95% confident that that's a possibility of the one in there. Now, some of you are going to look at this and be like, but wait, 50%, that's like, you know, more than half the interval, or, you know, there's only like some of the interval that's below 50%, so, you know, that means it's not possible. It might be lower or might be higher, but you don't know which of the values it is. You just know it's somewhere in here. It gives you a range of possibilities. That's the problem of precision. It doesn't give you the exact true proportion of all candies. It just gives you a possibility. So you look at this, you notice 50% is in there, so you can say, yes, it is possible that orange is 50%. Sorry, of all candies. You don't know if it's more, you don't know if it's less, you just know that that is possible. And you can't say anything more than that. So be careful. Anytime somebody tries to tell you that something is absolutely true or is absolutely equal to something and they're claiming to use statistics, you should be highly suspicious of them. One of the things that Stat 1 should have taught you is that a lot of what you see getting interpreted in statistics should make you suspicious of what people are reporting to you in the world. Statistics 2 should make you the most skeptical person in the world. Good times. Okay. I am now going to read number 2 out loud to you. So if you're already sick of my voice, I suggest you pause this or fast forward it and read this to yourself. Maybe. I don't even know. Should I bother reading this out loud? I'm not reading it. Okay. So we're going to select a random sample of 300 customers from the file. If you've never selected a random sample before, this is going to be new for you. It's in a little bit of an unusual spot. In Minitab, we go up to Data, and I just showed you the wrong place to go, which I never remember this is in the calc menu. We're going to calc, random data, and then we're going to sample from columns. Boop. Okay. It's going to ask you, hey, how many rows would you like to sample? AKA, how large would you like your sample to be? I want 300 people. The next thing it's going to ask you is, where do you want to sample those columns from? I'm going to put in age. And then the last thing it's going to ask me is, where would you like to store those? I'm going to store them in C3 for fun. Okay, so couple things to keep in mind when you're doing this. If you're doing a sample where you have multiple variables or multiple columns worth of information that you want to sample, you'll need to make sure that the store samples in area has the same number of places to place those samples as you want your sample to be. So say if I wanted like age and gender and number of children and income, there's 4 things. I need to have 4 places to put those. So if that was the case, I would do C3 dash, so C3, 4, 5, and 6. So that's if I wanted to sample more than one, but I'm only just doing one column, so I'm good. The last thing is there's this sample with replacement box. That means if an individual is selected into your sample, they're put back into the population and can be selected again. This means that you may have more than one of the same people in your sample. We really don't want that when it comes to humans, so I'm going to go ahead and not check that box. Let's go ahead and hit OK. And there's our sample. The last thing I do is when I select a sample, I always make sure I label it appropriately. So this is sample of age. I usually also do this as an S because it's shorter. And then I usually put my sample size, just in case I have multiple samples rolling around. So this is my size 300 age sample. Okay, now I'm going to code the data. If you've never coded data before, this can be a little bit of a complicated process. What I want to do is I want to take my data and make it so that anybody who's over 60 is labeled as a yes, anybody who's under 60 is labeled as a no. The reason you want to code your data is because when looking at this, it's numerical, and we want to do a proportion. We want to see the number of people that are above 60. But Minitab can't tell just by looking right away when you're performing a test who's a yes and who's a no, or who's over 60 and who's not. So we're going to have to tell it how to label the data that way first, and then perform our test or create our confidence interval. So I'm going to go ahead and code the data with yeses and nos because I need to have some defined success and failure to be able to do a 1 proportion confidence interval. So up we go to data. Now I'm choosing rightly. And then we're going to code, and then I'm going to choose to text. So basically I'm going to take my data and make it look like text. I'm picking text because I'm going to use yeses and nos. I like yeses and nos because it makes it clear who I'm keeping track of. One of the common things you're going to see if you get someone else's data is more often than not people will code rather than yeses and nos when there's only 2 options, 0 and 1. So like maybe if you're looking at upperclassmen versus underclassmen, you would do 0 for under and 1 for upper, and this is a really common characteristic that you'll see. But then you got to clarify what 0 and 1 are for that data type, and I like yes or no better. All right, so I'm going to go ahead and hit to text. And you have to be very careful because there's a lot of options in here. So I want to code for them the following column. I want to code for my sample. Now, the first thing it does when you put something in here is it tells you what your minimum and what your maximum is. So whenever I'm doing this, I want to make sure I include everybody in my values from my min to my max. So if you have a different number here, like 23, or a different maximum, like maybe 100, you need to make sure that you go over those values to make sure that they're included. So the next thing it's going to ask me is method. I'm going to do a range of values because if I choose individual values or single value is useful if you're only coding one group in the entire group. Individual values is great if you want to code them individually. So I don't want to sit here and code all the numbers between 24 and 96. So I'm definitely not doing that. So I'm going to be coding a range. So it's going to ask you for your lower value, your upper value, and then the coded value. So what I want to do is I want to assign no to everybody who's under 60. So who's under 60? People that are 59 or younger. So I'm going to put my lower endpoint as 0 because that's what I feel like doing, and because that is smaller than my minimum 24. So that's making sure that anybody who's at the minimum value of 24 gets coded as a no. That's about it. Now, and for my upper, I want 60. So people 60 or older. So now when I'm choosing my upper for my next grouping, it just needs to be bigger than my maximum. So there's nobody over 100 in here, so I'm going to put 100 in there. And the last thing I'm going to do is I'm going to put a yes in here, but I'm going to type it similarly to the other one because I am being anal today. Okay, so Couple other things. When you're coding, you got to make sure that your codes look the same. So like, what do I mean by that? So think of my upper lower classmen example. If I was looking at this and my options were freshman, sophomore, junior, senior, then I want freshman and sophomore to be labeled as no's because those are my underclassmen. And I need to make sure that I type those no's exactly the same looking, otherwise they might look different and get treated by Minitab as being actual different things. It's not able to tell the difference. Okay, so the last thing is I'm going to change this from lower endpoint only to both endpoints. What that's assuring is that it's rounding at these values and these values to place people into their appropriate cubbies. The last thing it's going to ask me is, hey, where do you want to store this? And I have selected at the end of the worksheet, which means it's going to make a new column at the end that does this. And it also, I have checked the box that says summary table. What that's going to do is it's going to tell me who it coded and what it coded at and how many times it did it. Good times. I like this option because it also will tell me a little bit of what my data looks like if it's huge, which mine is 300 and I'm not going to go through and count. Let's go ahead and hit OK. All right, so there's my coded age, coded S age 300 because that was the name of my data with yeses and nos. You can quickly eyeball this and be like, oh, they're yeses and those are nos, and this looks pretty good. 66 is yes, but 50 is a no. You know, it looks correct. I don't suggest you crawl all the way through this and make sure it worked. What you should check is, does this add up to be 100? Yep, it does. That means I managed to code everyone. Cool. Keep in mind as you're looking this, we did a random sample at the beginning because that helps us meet the conditions for being able to use the sampling distribution. And, oh gosh, what was I going to say? So your sample is going to look different from mine. So when I go to do my answers, like my sample is going to look different from yours. So your number of rows here with your no's and yeses could look different. Just like when I go to do the confidence interval, it could look different. So quick little review now that we're getting a little stuck in what we did. In step 1, we went to calc, random, data, and then sample from columns. And then in step 2, sorry, I usually code this with a color so you can tell the difference amongst them. In step 2, I went to data, code, and then to text. Just so you're keeping track. All right, in step 3, I'm going to go to someplace familiar that we've used before, as in we just did a problem like this. I'm going to go to stat, it's like where everything is in this class, basic statistics, and then I went to one proportion. And then dot dot dot. If you notice, Minitab is very non-committal. It's like, I'm waiting to finish saying something. It likes to do dot 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 at the end of everything. I don't know why. That's a little weird. Anyway, so I'm going to do the confidence interval, the 95%er for donors age 60 or older. So I'm going to go up to stat, basic statistics, down to one proportion. And now I'm not doing it with summarized data. My data is in the worksheet, so I want to tell it I want to do that. So I'm going to switch this drop down to one or more samples in each column. I click into the white space so that my stuff appears, my variables, and I want the coded variable. Remember, you can't use these two because they have too many options in them. It has to be a yes or a no, so that it has two options, so it can do a define success, define failure. I'm going to hit my options button, make sure this is set to 95% and not equal to and in a normal approximation, and normal approximation mode. We're going to click OK, and then click OK again, and it produces this lovely output for us. Woohoo! Oh no, that's super not going to fit in my Word document. Okay, let me adjust this a little bit so we can read it more readily and answer the questions using it. Crud. Okay. Oh well, it's not going to fit. No, just enter it down. This is the most boring thing I've done in a while. Okay. Whew. So, margin of error. Hey, this looks familiar. We've done this before. How do I find margin of error? I'm going to take the upper value, subtract the sample p, and that will give me the margin of error. So that's going to be 0.616 170 minus 0.56000. I'm hoping at this point you're like, oh my gosh, my numbers don't match hers. Of course they don't. We all did random samples. We're all going to look slightly different. So as I'm typing this, you should be typing up your numbers, the upper part of the interval minus the sample p, and then pulling out your calculator again and doing this. Where's the clear button? Is it this? Nope, that's the history button. Ah, I'm blind. It's fine. Okay, 0.616170 minus 0.56 bunches. Those are completely unnecessary to put in there. Okay, there's my margin of error. 0.065617. So a little bit bigger than 5%. So that's our margin of error. I'm going to highlight this so that if when I look back at it later, I know which part is my answer and which part was my work. All right. Write an interpretation of your confidence interval. Let's do this. Okay. We are 95% confident. I'm going to make this different looking because right now it looks the same as everything else. Let's go for purple. Pretty. Okay. We're 95% confident that the proportion of, oh crap, do I remember what this is? If I don't, I should scroll back up and like read my words that I should have known already. Like, what am I looking at? People who donate. Sorry. To the organization that are over 50. Sorry. So I want to say like you're 95% confident the proportion of donors to the organization which are over 50, 60 is between, my typing skills are seriously lacking today. What is it? 61.617. And I'm being a little bit more decimally than normal just because I want to include like details, peoples. 383%. And I should have put a percent on that one too. I like to represent these as percents because for some reason we do all of our calculations in proportions, but we tend to report our confidence interval with percents, which I don't know why that is. Maybe it's only a habit I have. Guess we'll find out. Okay, let's actually answer the question. Hey, should we advertise in the magazine? And your boss was like, oh my gosh, we're only going to do this if it's, going to be over 50%. Here's the thing. 50% and over is in there completely for mine. Yours might not have that happen. You might end up with a possibility that it might be lower. So you should answer this differently than what I'm going to say. So if you did your random sample and got something that included below 50%, you should say, it is possible that the amount of donors that are below 60 is under 50%, and therefore I should not advertise in the magazine. But from what I'm seeing, it looks like 95% of the time for my sample it will be. So I would say yes, they should advertise in the magazine since over 50%, or sorry, let me be more specific, since the confidence interval is above 50%. Okay, so that's about all I have for you for doing confidence intervals with Minitab. If you want more examples, please return to Blackboard and look at the examples for Chapter 10.